Okay, so this problem says at the end of an advertising campaign, weekly sales declined. The weekly sales are modeled by this equation. Okay, so let me just say a couple of things, uh, just so because some of this is a little, it'd be a little confusing at first. Um, and I'm going to try to use this tool here. But what's happening here is that you have this exponential decay function. And we know it's exponential decay because of this negative exponent, and also they're saying sales declined. Now, this end of an advertising campaign, I think that language is a little confusing because actually x equals 0 is the end of the advertising campaign. And so at the end of the day, this part of the graph is not important to us because that's sales before the end of the ad campaign. And this may not even be uh, an accurate model. We're interested in just this side. We're interested in this side, okay? So then, with that said, hopefully that sets the stage a little bit. Um, it says determine the sales at the end of the campaign. So I just told you that you have to plug in a 0 because that's the end of the advertising campaign now. Sales continue to decline after the end of the advertising campaign, but when they say the end of the advertising campaign, we're going to plug in a 0. Let me make the 0 this color over here. And what you'll want to remember is that of course, well, the first thing you'll want to notice is these are equal to 0, right? Anything times 0 is 0. And then you'll want to remember that anything to the 0 power is 1. So this is 12,000 times 1, which is 12,000. So the answer to part A is just 12,000, which should have made sense anyway, because whenever you look at exponential functions, this value is the starting value. That's this value right here is 12,000. And so, all right, so that kind of takes care of that. Now, 6 weeks into the campaign, that value is somewhere, I don't know, let's say it's over here. This is 6. So we're going to plug in 6. Just to make it easy for me, I'm going to put in a 12. I'm going to write 12K just to, it's a little hard to type with or to write with my mouse here. So, and we're going to do this to this, we're going to plug in a 6 for our variable X. And really, I can't do this by hand, right? So I'm going to try to bring in my calculator if I can find it. Let me find a calculator that I can use. Okay. And so it's 12,000 times 2 to the parentheses negative 0.08 parentheses 6. Let's just check that everything typed in correctly. Okay, so there's the formula, which I believe am I sharing the calculator?
Yeah,
Can my audience affirm that you're seeing the calculator?
yes, sir.
Yeah, we can see it.
Okay, perfect. So then I think I've plugged in everything in correctly, and I'm gonna press enter. So sales is $86,603.73. 8603.73. So equals 8603.73. We'll just put it there. All right. And then the last thing, does the model indicate that sales eventually reach 0? And if you understand these uh, functions, you know that no matter what we plug in for our variable, whatever we plug in for my variable here, I know we see a negative here, but this will always be a positive number. Now, this minus sign will likely make this very small. Even if this goes real big, what this ends up being is a fraction. And the bigger you plug in a number, the smaller the fraction you're going to get, but it's still going to be a positive fraction. So a positive times a positive is a positive. Basically, what I'm trying to say is that this function continues to stay above the x-axis. So it never reaches 0. It never crosses the x-axis. Don't ever expect this to go below. That's never going to happen. So, and it'll never reach 0. So that answers that question.